Welcome back to All This Math. This is Professor Parker. Please make sure you are subscribed to the All This Math YouTube channel. Make sure you like the video, share the video, drop a comment. Also, shout out to Collegiate Lux for the hoodie, for the Morgan State hoodie. I'm an alumni. You might already know that. Class of 2003, school business. That was back in the day before I decided I wanted to be a teacher. Best decision I ever made, you know. But at any rate, let's get into this. Today's lesson is subtracting polynomials. All right, subtract. What does that mean? To take away, right? Take something from something. What's a polynomial though? That word is intimidating to a lot of people. Don't let it intimidate you. All it means is this. The prefix poly means many or more than one, right? Nomial, right, is a name, right? The name for something. Or we can refer to this as a term. So more than one term. So this is a polynomial. Why? Because it has 1, 2, 3 terms. Terms are separated by plus or minus signs, right? This is called a binomial, which is a type of polynomial. Poly means more than one. It could be a binomial, which is 2 terms. It could be a trinomial, which is 3 terms. It could be a 4-term polynomial, which is 4 terms. A 5-term polynomial, which is 5 terms. This is a trinomial. A tricycle has 3 wheels. This expression has 3 terms. 3x squared is 1. 9x is 2. 6 is 3. Over here, this binomial. 5x is 1. Negative 10 is 2. Notice what I said. Terms are separated by pluses or minus signs. So this is a term and that's a term. Now, some people get it confused. They might think that this has 3 terms. Why do they think that? Because they're trying to separate the 5 from the x. You don't separate the 5 from the x. The 5 and the x is like a pregnant mother and the baby that's in her uterus, right? They're together. They are together. Until that baby is born, they are together. They're inseparable. They are going to be together. All right, so the 5 is like the mom, the x is like the baby. Think of it that way. So this is one term, all right? This 9x is one term, right? 3x squared is one term, all right? So how do we subtract these? Now, this is how I do it. This is subtraction. Subtraction is a little different than addition. Addition is just straightforward. Addition, you can just drop the parentheses and just combine like terms, all right? With subtraction, you got to be careful because everything in the expression after the minus sign becomes the opposite, sign. Why does it become the opposite sign though? Because this minus sign is really saying -1 times everything in this binomial. That's what this minus sign means. So you got to know the language of math. You got to know the language of algebra. You got to know what these symbols and these signs really mean for real. So this is -1, right? The minus sign means -1, right? You don't got to write the 1, but it means -1 being multiplied or distributed to the 5x and to the -10. To the positive 5x and to the -10. If we drop the parentheses in this trinomial, we could do that. That's cool. That's not going to change nothing. So let's do that first. Let's drop these parentheses, and then we're going to multiply -1 by everything in here. We're going to drop these parentheses in this one, right? Because ain't nothing going to change in here, but everything is going to change in here because of that minus sign. Keep in mind. Because of this minus sign, everything is going to change. Whenever you see a problem that look like this, when you see a minus sign, be very careful. Be very careful because everything immediately after it, notice I said the word immediately, right? Why did I say the word immediately? Because think this. If there was another expression that was being added, like plus whatever, right? This minus sign wouldn't have nothing to do with that extra expression. It wouldn't. The minus sign only affects what's immediately after it because that's like saying -1 juxtaposed, which means right next to, you know what I'm saying? Right next to this 5x minus 10. So this -1 will be multiplied by the 5x minus 10. So let's get into it. All right, so we got 3x squared plus 9x plus 6. Now, this is not going to be 5x. This is -1 times 5x, which is minus 5x. And this is -1 times -10. A negative times a negative is always equal to a positive. So a -1 times -10 is going to be positive 10 or plus 10. Now your parentheses are gone. Now we just play the game. The game is what? The game is called combine like terms. Now first what we got to do is we got to identify the like terms. Then after we identify them, then we can combine them. So basically we're going to separate these terms into their own groups. So all the x squareds are going to go together. All the x's are going to go together. All the constants are going to go together. So I say, okay, I see a 3x squared right here. Are there any other x squareds? I don't see none. So therefore, 3x squared is in a class all by itself. All right? 9x. I see an x right here. How many other x's are there? One right there, -5x. All right, the coefficient don't matter. The coefficient don't matter. The coefficient don't matter. We care about variables that got the same exponent. If it's a variable with the same exponent, then they're alike. They're like terms. They get grouped together. Now, some people might say, but I don't see no exponent. You're right, you don't. When your exponent is not written, that means the exponent is a positive 1. So this is x to the first power. This is x to the first power. It's all about the language. Math is a language. You just got to learn the language. That's it. You got to learn the language. Once you learn the language, a lot of things are going to start making more sense. So we got 9x right here. We got negative 5x right here. Then we got a constant, 6. Are there any more constants? This is a 6. This is a 10. They go together, right? Some people might get confused. They might say, well, but what about this 9 right here? Isn't that a constant? What about this negative 5 right here? Ain't that a constant? What about this 3 right here? Ain't that a constant? It is, but they're not written by themselves. Once you attach a 3 to an x squared, you don't treat it like a constant no more because it's a coefficient, right? The x squared is more important. Once you attach this 9 to an x, you don't treat it like a constant no more. You don't treat it like that no more because the x is more important. Once this negative 5 is attached to an x, you don't treat it like a negative 5 no more by itself. It's attached to the x, so that means it's part of that term, that x term. So this 6 is a constant because it's by itself. This 10 is a constant because it's by itself. All right? So then we're going to group these together. You can put a check mark on top. You can draw a box around it. You can put a circle around it. Do whatever you got to do. All right? So now, the 3x squared is not going to be added to anything. So we're just going to rewrite it. But the 9x's are going to be, the x's are going to be added together. So we got 9x minus 5x. Do not forget about that minus sign in front of the 5x. Don't forget about the minus sign in front of the 5x. You use the sign that's directly in front of the like term. There's a minus sign in front of 5x, making it a negative 5x. So if you combine positive 9x with negative 5x, that's like doing 9 minus 5. Because you got 9 x's, and you're taking away 5 x's, leaving you with 4 x's. So that gives you plus 4x. Then you combine the constants. You got positive 6, positive 10. Positive 6, positive 10. That's going to be plus 16. And all these are unlike terms. So what we're doing, like, dig this, right? Like, this is called simplifying. We're subtracting the polynomial, this one from this one, but we're also simplifying a bigger expression. We're simplifying it, right? Because this started out with 1, 2, 3, 4, 5 terms. 5 terms, but it's kind of like, why would you use 100 words to say something that you can say in 20 words or 15 words, right? In math and algebra, just like with language, we want to be more efficient and economical with our use of language. So we started out with 5 terms, but if we can express something that started out in 5 terms and only 3 terms, then that's what we're trying to do, right? Look, I end up with 1, 2, 3 terms. We started out with 5 terms. We end up with 3. We started out with 5. We're simplifying. Subtracting or adding is a form of simplifying. We're simplifying a polynomial expression. Remember what a polynomial is. Poly, prefix poly means more than one. Nomial means a term. All right, a term. 3x squared is a term. 9x is a term. 6 is a term. They're different types of terms, but they're terms. And remember, like I said earlier, I can't stress this enough. Terms are separated by plus signs and minus signs. Terms are not separated by multiplication. If that were the case, then 9 and x will be considered separate terms. They're not. 9x is one term. Because that 9 tells you that that's how many x's you got. You got 9 of them. All right? So this is our final answer. 3x squared plus 4x plus 16 is our final answer. We did the subtraction. When you see a minus sign in a problem like this, make sure that you remember that this is really a negative 1 that's being multiplied or distributed based on the distributive property to everything inside the parentheses. And that's how you get rid of the parentheses. That's how I do this. But if I'm doing it like mentally, I wouldn't even get rid of the parentheses. I would just know that I would do 3x squared, boom. Now, if I'm doing this like as a student, not as a teacher, trying to explain everything step by step so people can actually understand it for real, then I'm going straight to the 3x squared. I'm going to say, all right, I got 9x right here, and I got negative 5x right here, because that's negative 1 times 5x, and that's going to bring me 4x. And then I got 6 minus negative 10 minus a negative is called a double negative. When we deal with double negatives in algebra, 2 wrongs make a right. Double negative, that becomes addition. That becomes a positive. So this becomes 6 plus 10. 6 plus 10 gives me that 16. So I just want to put that out there because a lot of times people watch these videos and they be like, this too much, that's too long, why we got to do all that? Listen, I break it down step by step and go slow so you can see it, right? But once you get the hang of this, you're not about to sit up here and take 10 minutes to do this one problem. Understand that, right? If I was doing this as a student for my own benefit, I'm done this problem for real, I'm done this problem in like 20 seconds. Real talk, I'm done this problem in like 20 seconds, right? But the fact that I'm explaining it and going through step by step so that the viewers, whoever you are, can understand it, that's why it's going to take a little longer. So I just wanted to throw that out there just in case somebody got a little uncomfortable about why we got to do all this and they think it's too tedious and too laborious and all that. It's really not. But anyway, final answer, the difference between these two expressions, 3x squared plus 4x plus 16. Make sure you tell people about the channel. Go practice some problems like this. I'll see y'all in the next video.